So Spinnaker is designed for microservices and delivery for cloud-native applications. So what we are finding is in the enterprises, there are all these legacy applications, some of them that can be migrated to cloud-native forms, some of them cannot be, right? These are legacy applications that run on native platforms that don't mend well unless they are re-architected. So, but as they adopt Spinnaker, there is a need to have a single tool that can do deployments to the legacy applications as well as the cloud native ones. So that's where we help some of our customers and wanted to share that with you on what they're doing and what are the different applications. Some of them run through Jenkins deployments, some of them are the enterprise tools like IBM Urbancode or RLM tools from these guys. So those workflows, how do you migrate to Spinnaker? And what does it take? And does it make sense? And if it did make sense, what are the migration strategies? So those are the things that we will discuss today. So now the question is, why Spinnaker, right? So as we look at the automation today for the deployments, some of these are shell scripts that are run on Jenkins, or ad hoc shell scripts or Ansible scripts that run, which they don't have a handover policy. If you're going to ask them, so what is your delivery process for me to have a continuous delivery? There is no clear answer. There is a lot of ad hoc manual processes, handovers that happen. And there is no really continuous part to it, right? And Spinnaker is a very good orchestration tool. If you look at what Spinnaker is doing, it's allowing you to orchestrate complex workflows very easily and visually presentable form in its UI. It's one of the cleanest UIs that you will see. So you can orchestrate these complex workloads, bring that visibility to both dev and ops, and have this handover mechanism that's coded up. And now it's easy to explain what is going on and also to know what is being deployed. Right? So that's one of the reasons why we Spinnaker use. And of course, Spinnaker is an open source platform. All the enterprise tools that like your Urban Deploy, they're not open source and can get very expensive very soon as you go to scale. So in the migration considerations, what do you do? How do you decide how you want to approach this migration to Spinnaker? Right? So here we would consider the type of applications. Now there are some scripts that still run with Jenkins that go deploy to Kubernetes. Now these are really good candidates to actually convert them all to Spinnaker. Spinnaker has this native support for these cloud platforms that allow you to do different deployment strategies, as well as allow you to visualize these applications, allow you to do a canary analysis on these deployments. So it makes sense to have it as a clean deployment strategy with move them out. However, there are some things that we have run in scripts that run on your native platforms or infrastructure. And Spinnaker doesn't have support for that. And also, you can't really have these deployment strategies built into those kind of scripts. So then it's probably better to use them as is, but as part of the custom stages in Spinnaker, right? So those are some of the things we'll look at. Now, if you probably have seen this kind of a continuous delivery clean, there is a CI, and then deployment with the handover process, and with the strategies on how you deliver them. This is a process that you would have seen, but when you look at internally how these things are done, it's a fairly complex process with multiple teams involved in the software delivery in a traditional software systems, right? Where you have three-tier systems, monoliths, those have a specific build process, handover process that happens to QA, and then there is an operations team that comes in that takes the build and deploys in their own form. So there is a lot of handover that goes on. It's not as clean like microservices where you could build this pipeline out and do it. So if you go and ask us, one of our customers, what do you do today in this process? This is the kind of a flow chart that we came up with, right? Oh, it was my noise. So this flow chart, as you can see, it shows how the code is handed over to QA and how they make the decisions. The testing comes up with, it's not fully automated tests. There are some automated tests, some manual tests, and then there is a handover process. There's a manual judgment that happens through a product owner that says, okay, now we can give it to staging. There are no critical issues that are involved, and hands it over to operations, then operations goes and deploys it. Now, this is the kind of a thing where the visibility gets harder for the enterprise systems. The development does not have the ability to diagnose the issues faster. The operations don't have a clean way of communicating the process improvements to dev, etc. Right? So now bringing in Spinnaker in this mix, as you can see, Spinnaker fits in right in the center because it can be an orchestration tool. As you deploy the code, check in the code into the Git, you can see there is a trigger that kicks off a Spinnaker pipeline, which could then be used to use the Jenkins. You do the build. The build generally does the artifact push. It can be any one of these artifacts. Right? It can be a jar file. It can be a container, any one of those. And then, depending on your situation, you could bring up the infrastructure. Let's say in the test environment, you want to bring the infrastructure up and then deploy. You could do the Terraform infrastructure and then deploy on it. So this is a typical process. Now, what we are, as you can see, we also introduce something called Ansible there, Terraform or Ansible. Now, you have a bare metal platforms or scripts that you're doing the install. You could have custom stages of Spinnaker that can extend and include those as part of your pipeline. Right? Now, so what are these Spinnaker extensions? So Spinnaker provides multiple ways of doing the extensions today. There is a new process that's being worked on as a plugin process, which would make it a lot more integrated with Spinnaker. Today, it supports integration with Jenkins. You can run arbitrary scripts through Jenkins. So there's a very two-way integration with Jenkins that you can pass the parameters to Jenkins pipeline, run the pipeline as the output from the Jenkins. You can bring it back into the Spinnaker, have them parameters output that can be used in subsequent stages. So that's one way of doing it. Another way is to have your own custom service that runs. And now from the Spinnaker, you could have something like a webhook that calls out, runs, executes your job. Here, you can implement your policies, some kind of checks that you want to do before executing your scripts. And then that becomes a part of the pipeline stage. And the other way to do it is if you already are using Kubernetes, then you can do something like a run job. Here, you can use the scale of the Kubernetes as part of your pipeline. And this run job, you would be doing one container job for each of the type of workload. And as part of the Spinnaker pipeline, you would instantiate one of those stages. Now, the issues involved there will be how do you make sure the permissions are correct? How do you make sure the accounts are properly configured? If there's some secrets need to be passed on to the job, how do you do that safely, right? Now, if the simplest one will be the Jenkins part. So if there are deployments that are going through Jenkins, generally these deployments will be some kind of shell scripts or cloud integrations that you have that call directly, right? This, if you want to bring into the Spinnaker, let's say these are shell scripts that you're running. After the build artifact is built, some kind of a WAR file, it does some kind of a SSH into a VM and copies the file there, or invokes something else that passes the artifact to it, right? So here, Spinnaker provides this ability to call in Jenkins job. As you can see, these parameters that can be passed on to the Jenkins. And the parameters that here you see are automatically detected by Spinnaker. When you declare a Jenkins job, you also declare what are the parameters that go into the job. Then once the Spinnaker detects them, these can be now triggered as part of the trigger that comes to the Spinnaker pipeline that gets passed on to the Jenkins. Or there are defaults that are specified, you will continue to use them. And once the stage completes, the output from Jenkins will come out in status.out. These are the output files that are archive files generated by Jenkins that will specify some things like what is the war file name or a jar file name that you would use in the subsequent stages. In the case of AWS, you will take a jar file and bake another AMI to deploy, for example, or in the case of a Docker container, it can give you a container ID, or it would just simply give you the identifier that says this is the VM that I want to be connected to, right? And so in a common workflow here, typically for Kubernetes or AWS, the dev deploy after the bake stage would use the native libraries of Spinnaker to go deploy to the cloud environments. But here, now that we are using the deployment as a Jenkins, that would again be a Jenkins job that we would run. Right? So after the build is done, you would just call a script that would run it. So the advantage that we are getting here is the handover process is cleaner. It's similar to what the rest cloud native platforms that we are using. You can also run automated tests. We'll show how you can do that in the canary analysis. That doesn't necessarily have to be the cloud native. It can be done on native platforms. So that's something that we can do with Spinnaker. And then you can have privilege escalation that part of the pipeline that's visible to both dev and ops. Right? Now, if you look at the other tools like IBM Urbancode, anyone here you know IBM Urbancode? You do. Okay. So this is a tool that's designed for the deployment. You would have the shell script kind of stuff that you would run on arbitrary platforms. It's broken down into small scriptlets that you can stitch together. So it's purely an orchestration system, really running different shell scripts. In the newer systems, they also provide cloud drivers and stuff, but it looks fairly complex like that. This is the simplest that you can do with urban deploy kind of a thing. So each of these scripts then are executed in sequence. It tells you whether they succeeded or not. These kind of systems, then you want to be able to migrate out to Spinnaker stage, not exactly this form, but you can automate this migration. So with the urban deploy, you would go look at all the scripts that are running, what stages they're running in, and then combine them into one container job. So you will take all these scripts, put them in one sequence, have a Uber script that generates that runs exact same sequence, and then you can put it as a stage in Spinnaker. So that way you can completely eliminate this Urbancode deploy, get the visibility and simplicity of Spinnaker along with other cloud workloads. So typically, this is how it would look like, where you have the Spinnaker. Spinnaker would have a run job that would go run the job in the Kubernetes. It will be like a bastion service that runs, which will then connect to your VMs and executes the sequence of shell scripts. Right? The bastion here, the interesting thing is you have the secrets that you would need to connect to the bastion. Now you have to make sure the user that's invoking the pipeline has access to those. So that is done by Spinnaker account permissions. Right? You can set the permissions up for the namespaces on which they are invoking, and you'd have those secrets that are set in that specific namespace. And you can use that account permissions with the secrets to be able to run safely on the VMs. So you have these shell script arbitrary scripts that you would run. For example, if you have a Tomcat service that is running, you have a new war file that you want to deploy. So Jenkins will build the war file, push it to your Artifactory, and then trigger the Spinnaker. Spinnaker would then launch this job, which has the container, the entire script, and pass the credentials. So it will pull the artifact from Artifactory and use it as a bastion, and use the secrets for the VMs to connect SSH, connect to them, and deploy that. So now you have the entire process of deploying to regular VMs as urban deploy or a simple script as part of the Spinnaker pipeline, As you can see, because in the Spinnaker, you can also do privilege escalation, the visibility. You get all those features. And when you go to the infrastructure tab in the Spinnaker, I'm sure if you're familiar with that application view, you could actually see the VMs that are running, and if you can extend that to show the versions that they are running. Right? So the converted pipeline would simply look like this. You would have a configuration stage where the trigger comes in. The user passes in the parameters saying, this is my list of servers that I want to deploy on. And you pass the artifact. And the deploy stage would just go deploy to those VMs. It will run a job, pass the variables to it. The job will then take those variables, run in a specific account, which has the secrets, and it will go apply that to the VMs. Now, you can see the verification stage is a manual verification. You can have the privilege escalation by ops person before you deploy to production. So that way you also get the advantage of having the visibility across both dev and ops with manual verification, promoting the privileges higher, and then you can promote to prod. Prod here will essentially the same kind of a VMs, but it's a different set of VMs, right? And this one, because we are using it in Spinnaker, you can also use the strategies that are best practices here in terms of canary deploy. Right? So how is this custom stage done in, say, in Kubernetes? In Orchestrator, Orca, there is an ability you can specify in the configuration saying what is your job. Right? That shows up as a custom stage. Here in this particular case, we are saying that this is a Kubernetes job. And then these are the type of this is a name, and it uses these artifacts. Right? So by specifying that, we are able to say the custom job, which has you deploy job 1, would run a specific set of scripts in that particular namespace. So we can here pass the account information as part of the pipeline. And then you control, based on the user, what accounts they have access to. If the user does not have access to that account, it will not trigger. And then that account will have the secrets specific that are accessible to the user. Right? Yeah, this is essentially, once you have that script done, you can deploy that. So now, how can you use the canaries in this one, right? Now that we are using Spinnaker to deploy, let's say your production deployment has 5 VMs. Now, you could choose to upgrade only one of the VMs with the new artifact, and then run a canary analysis. The canary here, the automated analysis, is not specifically designed for the cloud-native applications. So maybe I can quickly show how that looks. All right, so here in the Kayanta, if you look at the canary analysis, how it's doing, we are specifying the baseline and canary. It's a flexible system. It doesn't have to be coming from a specific Kubernetes account or AWS. It can be, the source here is actually configured as a data source like Datadog or New Relic or Prometheus. So simply by specifying what is your VM that's generating data to these data sources, you can say which one is your canary and which one is your baseline, and then you can run the canary analysis on the new deployments that you're doing, even if it is a Tomcat that's running on a VM that you're just modifying the WAR file on it and restarting it. Right? So if you look at the canary configs and how they do, you can get all the data very similar to the configuration, and you can even look at the reports that it generates based on the metrics that you're doing. There are certain requirements on the metric analysis for the canary and baseline to have them similar conditions and similar kind of a load on them when you're comparing. But those are the things that we can take care of after this upgrade. Right? Does it make sense? Okay. All right. So going back, so we covered essentially saying if you have scripts that are done through Jenkins that are doing the deployment. Depending on what scripts are doing, whether they are doing a cloud native deployments or bare metal deployments, we would have different strategies on how we move them to Spinnaker. If they're doing some kind of a bare metal, we basically keep them in Jenkins, have the Jenkins jobs as part of the Spinnaker pipeline that we would call. We essentially get the visibility for them and the process for automation to move forward. When you're looking at the systems like udeploy or RLM, these are purely orchestration tools. They don't really bring much to the table other than what they're running the scripts. So those ones we would probably want to convert them and orchestrate through the Spinnaker itself, so you can completely eliminate those tools and have the deployments purely going through the Spinnaker. Okay. So these are the some of the automated reports that you would see. So ideally, you want to be using Spinnaker built-in capabilities for the cloud native deployments. Then you can get the features as is. But in case where you're not able to do that, or you have the bare metal kind of a systems, then extending Spinnaker is done through the techniques that we just saw with the Jenkins or run job.